Hi everyone! In this lecture, we'll implement a block reward function in cryptocurrency. For this, we'll create a public function, giveBlockReward. In the definition of its function, we'll increase the balance of the miner who mined the block by block reward, which in our case is 1 T-coin. For this increment, miner's address is required, which can be obtained by a default method, block.coinbase. Once you obtain the miner's address, just increment it by 1. Till now, we've created a function by which a miner gets the block reward. This is one way of rewarding the miners. Another method by which you can reward a miner is proof of work. In this method, you have to provide a mathematical problem, and whoever solves this mathematical problem gets a reward. For this, create a public function, proof of work, that takes unsigned integer nonce as a parameter. In the function's definition, define a variable n of type bytes, which is of 8, and initialize it with bytes8, start bracket, SHA-256, start bracket nonce, current challenge, n brackets, n brackets. We are using the SHA-256 hashing algorithm. You can use any hashing algorithm you want to use. We haven't defined current challenge yet, so let's define it and other required variables. Define the current challenge using the code bytes32 public current challenge. This creates a public variable of type bytes32. Next, define another public variable of unsigned integer type time of last proof, which stores the time at which the last problem was solved. Next, define one more public variable of type unsigned integer difficulty, storing the difficulty of a mathematical problem given to the user for solving. We'll initialize it to 10 to the power 32. Next, we'll apply a check here, that the present difficulty should be greater than the previous difficulty. Require, start brackets, n greater than bytes8, start brackets, difficulty, n brackets, n brackets. After this, we need to calculate the time since the last problem was solved. For this, create an unsigned integer type variable, time since last block. To calculate it, subtract time of last proof from the current timestamp, which is denoted by the keyword now. This variable gives us the time spent by the user to solve this problem. Now, we'll apply a new check that time since last proof should be greater than 5 seconds. This is done to make sure that the user has spent a significant time in solving the problem. If a user has solved the problem in less than 5 seconds, then it will throw an exception. If all these conditions are satisfied, the balance of the user should be increased. The increment in the user's balance will be made according to the time he has spent to solve the problem. In our case, we are providing 1 T-coin for 1 minute. To implement this, or we can say that to calculate the time spent by the user to solve the problem, divide the variable time since last block by 60 seconds. This will give us some time spent by the user in minutes, and then we can increase the balance of the user by that many of T-coins. After this, we'll adjust the difficulty again, or we can say that we will increase the difficulty after the current problem gets solved. While adjusting the difficulty, make sure that the average block time remains the same. In this case, the average block time is 10 minutes. Difficulty equals difficulty asterisk 10 minutes slash time of last proof plus 1. Once this is done, next, we'll reset the time of last proof by assigning it to the current timestamp, because the problem is solved recently. Then we will modify the current challenge by taking SHA-256 of nonce, previous challenge, and the block hash. To get the block hash of a block, we have a default method, block.blockHash, in which we have to pass the number of a block as arguments to get the hash. Let's summarize this. First of all, we adjusted the difficulty. Then we checked that the current difficulty is higher than the previous difficulty. Then we stored the time spent by a user to solve the problem and checked the time is significant. After this, we rewarded the user T-coins on the basis of time spent by the user to solve a problem. We adjusted the difficulty to maintain the average block time, which is 10 minutes in this case. Then we reset the time of last proof to the current time. After this, we modified the current challenge. So this is how you can implement the block reward system functionality in any cryptocurrency. With this lecture, we have completed the third stage of cryptocurrency. In the next lecture, we will perform the execution to ensure all is working well. Thank you.